This is our actual conversion workshop. It's behind me. I'm giving this lecturing and sharing in our workshop. CMVTE.com is our website, and the full name, as I told you, is Convert My Vehicle to Electric. So we provide EV solution, one-stop EV solution, for worldwide customers. So we have the mission. We want to be the world's premier one-stop partner for electric vehicles conversion. Here we will see a video that is converted from diesel to electric. A 2000-year Volkswagen Golf MK4 converted in 2024. We remain the same chassis. We remain the same soul, reborn with zero tailpipe emissions. We're proving classic cars can need the charge in sustainable mobility. This is the picture of the MK4 Volkswagen Golf Car model. So let's see the video. It will be 2 minutes, 2.5 minutes. Our workshop, main buildings. Thank you. So actually this car is behind me. So let's move on. We move to part 2. We will share the technical roadmap and selection. So step 1, we need to first of all to assess the vehicle's condition. The first part you will see, we have to make sure the frame rust condition has to be good enough for conversion. There is no significant rust or corrosion, providing all uncompromised foundation for security mounting new electric powertrain components and ensure the long-term durability. Besides, we also need to check the suspension and the steering system. They have to be integrated. Must be in good working order, free of accident-related damage or excessive wear, to guarantee safe handling dynamics and seamless integration with new electric motor drive train systems. Brake system health. We need to verify the calipers, the rotors, lines, and the master cylinder condition to ensure that the reliable stopping power available there. And a robust braking system is a non-negotiable safety prerequisite before any powertrain modification. So we need to be aware that the brake system health before conversion. The fourth is the battery placement feasibility. We need to evaluate the engine bay, the undercarriage, and the interior space for optimal battery pack positioning. Prioritize and balanced weight distribution to preserve the vehicle handling and ensure no impact on structural safety, especially for high speed. So this is the assessment of the vehicle's condition. It's kind of comprehensive pre-conversion evaluation process. The common architecture of the conventional cars. You will see the front compartment. The front compartment originally housing all combustion engine and gearbox. This space is repurposed for placing the electric traction motor and is the power controller. Utilize existing structural mounting points for seamless integration. Front compartment. Second is the vehicle underbody. The fossil fuel tank is moved, and the central tunnel and the rear undercarriage are re-engineered to house high-voltage battery packs. So this placement optimizes the vehicle's center of gravity and weight distribution for better handling. The third, we need to remove all the emission systems. The entire exhaust manifold, piping, and emissions control systems are eliminated, removing the tailpipe emission entirely. This frees up critical space for additional electrification components and reduce the overall vehicle complexity. So the key takeaway for this part is this structurally flexibility enables the development of module scalable electrification solutions that can be adapted across a wide range of conventional vehicle platforms, streamlining conversion process and reducing the engineering cost. So this is the common structure of the conversion cost. So now we say the 5 basic conversion process that will be done step by step. First, remove the internal combustion engine, the fuel tank, the exhaust system, and all associated mechanical components from the vehicle. After that, we need to mount a high-efficiency AC electric motor, either it is AC induction motor or permanent magnetic synchronous motor based on the requirement of the torque. So configured to drive either directly or through the vehicle's original gearbox for familiar handling. The third is the install. We need to position the traction battery packs in strategic locations to achieve optimal weight balance, no center of gravity, and maximum safety. So this is the purpose and meaning for installation. And you know that we need to integrate the motor controller, DC-DC converter for an auxiliary power, and onboard charger for convenient, fast battery charging. Step 5 is the recalibrate. We need to adjust the instrument cluster, brake booster, and power steering system to seamlessly integrate with the new electric powertrain. So the result what we would expect to see is a fully functional, road-legal, zero-emission electric vehicle with optimized weight distribution, responsive acceleration, and reliable performance, engineered for safe and sustainable everyday use. I think this is our purpose for conversion. Yeah. Step two, we need to define the core components that's necessary for the conversion. Yeah. So first, let's say the traction motor. We need to utilize advanced permanent magnet synchronous motor or induction motor, delivering high torque and efficiency for reliable propulsion. Motor controller we also call MCU. Yeah, this acts as the brain of the traction motor, precisely dictating the speed and torque based on driver inputs and system demands for optimal performance. Yeah. Traction battery pack. The high voltage Nissan battery pack using LFP or NCM cell chemistry, which is the dominant two kinds of Nissan batteries in the market nowadays, providing the primary power source for the drivetrain. Number 4 is the BMS, battery management system. It monitors and manages the cell temperature, the state of charge, and health to ensure the real-time performance, operational safety, and long-term reliability. Yeah. Onboard charger and the power distribution unit we call PDU. So this supports from AC to DC charging efficiently, while the PDU intelligently distributes high voltage power across all critical environmental components. DC-DC converter. It converts the high voltage DC power from the traction battery to low voltage DC power. Normally it is the 12 voltage application. This is to supply the essential auxiliary systems like lighting, infotainment, and climate control. So these are the core elements that are necessary to install. So we can say the basic function of each part. Motor. The motor's function is that conveys electrical energy into mechanical power to turn the wheels efficiently. The key specification is we need to care for the selection for peak power, maximum torque, and maximum RPM to define the performance limits. Yeah, we will have that data afterwards. Controller. The function is the powertrain's command center, regulating electricity flow from the battery to the motor to control speed and torque. So the key specification of the controller includes voltage compatibility, the peak current handling, and the configurable setting for dynamic performance tuning. Battery pack, as we said, the function of it is the primary energy storage system that delivers high voltage DC power to electric motor and all vehicle systems. The key specifications for that is energy capacity, we define as kilowatt hour, for driving range, for cycle durability, and for C rate, for charging or discharging efficiency. These are all the necessary specifications that we need to check before we define the parts. BMS, it monitors and protects each battery cells, ensuring safety of the operation, optimizing the charging or discharging, and long-term health. The main specification for that is the cell balancing capability, advanced the thermal management, and active balancing for consistent cell performance. So these are the 4 component functions.